Bearings are an integral part of our day-to-day lives. They're in everything from vehicles and machinery to kitchen appliances and toys. Basically, if it rotates, it's got a bearing in it. Hi, I'm Dustin from your 100% Canadian industrial supplier, Gregg Distributors, and although you seem lost and confused, we're here to help you get your bearings. Even though bearings come in many different shapes and sizes, they all tend to be made up of the same base components. Let's start with the inner ring and the outer ring, which make up the main body of the bearing. Depending on the bearing type and application, one or both of these rings will have what's called a raceway, which is the groove the rollers move in and the contact point between the ring and the rollers. Speaking of rollers, these provide the load bearing and friction reduction in a bearing. Looking at the rolling elements is the easiest way to identify a bearing. If it contains balls, it's a ball bearing. How about cylinders? A cylindrical roller bearing. Are they tapered rollers? Then you've got a tapered roller bearing, my friend. Now, the piece keeping all of these rolling elements in line and in place is the cage. The cage acts as a guide/spacer so that the rolling elements are distributing the weight evenly and allowing the bearing to have a better rolling motion. Depending on the application needed, a cage can come in either steel or brass. It can also be machined out of a single piece, or it can come in multiple pieces that are riveted together. Also, you might encounter some bearings that are completely open, allowing you to see inside and make it easier to apply grease when needed. But some can come pre-lubed and enclosed by either a shield made out of metal or a seal made of rubber, plastic, or even felt. The different materials are there for chemical compatibility reasons, but they all essentially do the same thing, which is keep lubricants in and contamination out. Lastly, the radial internal clearance, or RIC, is essentially the amount of space between the rolling elements and the raceway. The extra clearance will help for both the installation of the bearing and any expansion due to heat. The amount needed will be determined by the equipment manufacturer. The RIC will come up later when looking at part numbers. The types of bearings will determine how well it can handle different loads or forces that the equipment is under. The main ones you'll be hearing are radial loads and axial loads. A radial load is a force that is perpendicular to the axis of the shaft that goes through the middle of the bearing. Think of a skateboarder riding in a straight line. All the weight of the rider is pushing down on the bearings in the wheels. That is a radial load. Now, if the skateboarder starts to turn the board, he's applying a side-to-side force, which is parallel to the axis of the shaft, which is known as an axial load. There are many types of bearings, but the most common is the ball bearing due to its minimal contact between raceway and roller, and therefore ultimate efficiency. A tapered roller bearing actually has its inner ring, cage, and rollers assembled together in what is called the cone, and then this fits inside the outer ring called the cup. Spherical roller bearings are designed to be used with misalignment, meaning that the axle that goes through the inner ring can move freely if needed. Cylindrical roller bearings are similar to ball bearings, but because it uses a cylindrical roller, they can hold higher capacities under radial loads. A thrust bearing is used to support predominantly axial loads between moving parts. You may even come across a housed unit bearing, which is a two-component system that secures and protects the bearing from contamination and other environmental conditions. The bearing world can seem intimidating, but now that we have a basic understanding, we can see that they are not an overly complicated part. The different forces, environments, and sizings required are the driving force behind so many variations. So what resources are available to help us narrow down from the thousands of available part numbers to the one we need? We have showmetheparts.com/Timken, where we can use the application search, part lookup, and cross-references for automotive-related bearing inquiries. There's also timken.com/engineering-tools, where we can look up bearings and seals by measurements, or even Gregg Distributors.ca, where more information on bearings will be available. All of these resources can be helpful, but by far the main resource will be the Timken Catalogue, available at catalog.timken.com, or the printed versions on your branch's counter. The catalogs tend to have the same sections within them. The engineering section at the start will show the different variations or configurations of each type of bearing, along with the cages it's compatible with. You'll see charts on tolerances, mounting and fitting instructions, and information on operating temperatures, torque specifications, and proper lubrication. When it comes to part numbers, each bearing type will have its own nomenclature, meaning that you can understand some properties of the bearing within its part number. Finally, within the catalog, you'll get into actual bearings with their product numbers and measurements. This section is laid out first by type, followed by bore size. You'll even see cross-section schematics that show the basic design as well as what the measurements in the charts below are measuring. So, what do you do when a bearing comes across your desk and you have to find a replacement for it? If the customer has a part number, we can try searching it in our system or cross-referencing it. If this does not work, then we're going to have to do some legwork ourselves. First, we need to identify the style of bearing. What kinds of rollers are present? Does it have a seal or shield? What is the application? What kind of loads will it be facing? What other identifying features are noticeable? Do we have a brand and part number that won't cross, but we can Google search to get more information, such as style of bearing? Although part numbers differ between manufacturers, the terminology used for defining features is fairly standardized. Secondly, we have to get measurements. All of Timken's catalogs are arranged by dimensions, so accurate measurements is crucial. Bearings are also heavily weighted towards the metric system, standardly in millimeters, but because we live in North America, we will run across more imperial bearings than other parts of the world. When measuring, measure in 3 or 4 different spots to account for wear and tear. Now we have a good basis of knowledge on bearings, how to identify them, and what resources are available to us. Watch for our next video where we will go into more details on the different bearing styles as well as the examples on how to identify them. Now that we've got your bearings, let's roll into the next video. We'll see you next time.